So we're going to work on how to verify an identity today, and this will continue to use the rest of the trig functions that we talked about, and a couple of new identities as well. So again, an identity is a statement that's true for all values of the input on which they're defined. And today the identities we're going to look at are going to have multiple trig functions, and we're trying to simplify them down. So a couple other things that'll be useful are these two Pythagorean identities. And what I'm going to show you is that if you just take our original identity that we came up with the other day and divide by cosine squared everywhere, that we actually get this first one. So 1 over cosine squared is secant squared, and sine squared over cosine squared is tangent squared, and cosine squared over cosine squared is the 1. And we can do the same thing for the other one by dividing everything by sine. So if I divide everything by sine, 1 over sine is the cosecant squared. Cotangent would be cosine squared over sine squared. And then 1 would be the sine squared over the sine squared. You can see it's identical to what we had before when we got started. And we're going to use these identities at times to change or to verify identities. A few of them will involve that if we need to. Some of them will most commonly involve sine squared theta plus cosine squared theta equals 1. And a little disclaimer on all of these problems, there are multiple methods of doing this correctly. So the problem being is some ways of accomplishing this problem could be a little bit more difficult than others. So whenever you're asked to prove an identity, I want you to note two things. There's a left-hand side and there's a right-hand side. Which one looks more complicated? Dramatic pause. Yes, the left-hand side is more complicated. So what we're going to be trying to do here is take our left-hand side and make it look like our right-hand side. So right now, I'm not using this at all. I'm going to wait, and hopefully we'll get that at the end. So the first thing I want to do is look at this complex-looking fraction. And I want you to notice that I've got a tangent squared. In this case, I've got cosine squared and sine squared on the top. I've got a tangent squared on the bottom. My first step here will be to change that into sine over cosine. And once I do that, I can combine the 1 minus that by changing 1 into cosine squared over cosine squared of x. That's just 1. So now my bottom becomes cosine squared x minus sine squared x. And since I'm combining these and they have a common denominator, I can make that cosine squared x underneath there. What does that do for me? Well, that does a lot of things. I've got a fraction, and I'm doing division. So I've got this top stuff divided by the stuff on the bottom. Well, when I divide by that stuff on the bottom, I can actually make that into the same thing as multiplying by the reciprocal. So I've got my top times cosine squared of x over cosine squared x minus sine squared x. And guess what happens? I'm left with just cosine squared x. So I just verified that identity. So we made our complicated left-hand side look exactly like our right-hand side, and that verifies the identity. So let's try another one. All right. And sometimes they're not going to be as complex as others, and sometimes they're going to be way more complex than others. I'm trying to give you some examples that are more complicated than what are in the book, for you to actually work on the problems, so that maybe it'll be a little easier than what you think. So I'm going to change tangent of alpha into sine of alpha over cosine of alpha. And the reason why I'm doing that is because my left-hand side is way more complicated than my right-hand side. So I'm going to ignore that right-hand side for now, and hopefully later on we'll get the answer right down here. Alright, so this is the left-hand side. It's way more complicated. So, a couple things here. I've got sine of alpha times sine of alpha. So that ends up being sine squared of alpha over cosine of alpha plus the cosine of alpha. Now, just like before, we have a fraction, and I'm adding something else on. So in order to add that something else on, I got to have a common denominator. So to make a common denominator, I need a cosine alpha underneath it. So that means it's going to be cosine squared of alpha over cosine of alpha. And now I've got sine squared plus cosine squared on top of cosine of alpha. We should know by now that sine squared plus cosine squared is equal to 1, so I've got 1 over the cosine of alpha, and that equals the secant of alpha, which is what we were looking for. Alright? Again, the more of these you work on, the easier they become. So again, one of the things we want to combine everything. We want to try to get rid of as many of the trig functions as possible and get this down to a single trig function, usually without fractions. So over here, we know what our answer is supposed to be. This is our right-hand side. It's way easier to... I don't want to try to expand that into the left-hand side. So that's our goal. Sometimes it's going to be the right-hand side that you're going to change, and your left-hand side will be your goal. That's up to you to decide when you look at the problem. Most of them, it's fairly obvious which side is the side you're supposed to change. So if you look at this for a second, hopefully as you look at this problem, you see, okay, I've got two fractions. I've got subtraction. Do I have a common denominator? In this case, no, you do not. They're very similar, but we need to get a common denominator. So that means to get a common denominator, I pretty much have to take this and do 1 plus sine of x over 1 plus sine of x times the first fraction, and do the exact same thing with the second one. So this one gets a little ugly really fast. We've got cosine of x over 1 minus sine of x, and then that's going to be times 1 plus sine of x over 1 plus sine of x. And then I do the same kind of thing with the second one. Except I'm going to do 1 minus the sine of x over 1 minus the sine of x. Alright? So now I've got the same denominator. I'm going to do a couple things. Number one, I'm going to multiply this cosine in here and distribute on both of these fractions for the top. So that gives me cosine of x plus cosine of x sine of x. Now you got to remember when you're doing this that this one, the second fraction, is subtraction. So I got a minus cosine of x that I'm multiplying by 1, so that's minus cosine of x. And then I've got negative and a negative sine of x, so that's plus cosine x sine x. And then my bottom, I do need to multiply this out. So I've got 1 times 1, which is 1. I got negative sine x times 1. So that's negative sine x. I got positive sine of x times 1, so that's plus sine of x. And I've got negative sine times positive sine, which is negative sine squared of x. Alright, we've got several things here that actually will simplify on both of these. On the top, my cosine goes away, and I've got two of the same thing. So I've got 2 cosine x sine x. On the bottom, my sine x's go away, and I'm left with something that should be familiar. I've got 1 minus the sine squared of x, so 1 minus the sine squared of x always is going to equal the cosine squared of x because of our Pythagorean identity. So that means over here I'm left with cosine squared of x. And now cosine on the top cancels with one of those on the bottom. So I've got 2 sine x over, I messed that up pretty bad there, over cosine of x. And sine x over cosine x is tangent x, so we're left with what we were looking for, 2 tangent of x. Alright, so before we move on, let's take a quick commercial break, and then we'll be right back to the action. Somebody told me in class that I needed to maybe put a song and dance in the middle. So I found a song and dance for you. This would be me dancing. I hope you enjoy. I hope you enjoyed that commercial break. And yes, that is exactly how I dance. So, hopefully you're looking at this thinking, alright, I know there's no way I can make 2 and all that stuff on the left-hand side. So maybe we should just work on the left-hand side. And again, this just happens to be the way the problems were that I found for these examples. It doesn't always mean that they're going to be that way. They could be 2 equals this other stuff. It still works the same way. You go for the complicated side. And we got all this stuff squared. We got sine x minus cosine x squared, and we've got sine x plus cosine of x squared. So guess what we get to do? If you said square it, you're the winner of nothing but some fun math. So we're going to do this squared. We've got sine squared of x and then I've got a sine times a negative cosine and another sine times a negative cosine, so that's minus 2 sine x cosine x, and then a negative cosine times a negative cosine would be a plus cosine squared of x. And then I get the same, very similar on the next one, except for there's no minus sign, so I get plus sine squared of x plus 2 sine of x cosine of x plus cosine squared of x. And again, we're trying to make this equal to 2. So I want you to take notice these negative 2 and the positive 2 sine x cosine x cancel out. And then how many sine squareds do we have? We have 2 sine squareds of x plus 2 cosine squareds of x. And if we factor a 2 out, we get 2, and then we get sine squared of x plus cosine squared of x. And that just becomes 2 times 1. And we were looking for 2, so guess what? We found the 2. So it wasn't as bad as what it looked at first. Sometimes there are, sometimes they're pretty easy. Like I said, you'll get the hang of it. And since these are rather long, I'm only doing 5 examples. So this is my very last example. Again, I tried to give you an example of every type of problem that you'll probably see with this. So Last one we had to square some things. Here, we're actually going to have to factor. Now, we're looking for a 1 at the end. Hopefully you know that I'm not going to be able to get all this gobbledygook just out of a 1. Not very easily, at least. So we're going to start with the top. And I want you to notice that sine to the 4th is just sine of theta that's been squared again, minus, and then the cosine does the exact same thing. And we're just leaving this sine squared theta minus cosine squared theta alone for now. Sometimes you'll work with the top, the numerator. Sometimes you'll work with the bottom, the denominator. In this case, I want you to notice this top part is a lot like the difference of squares that you may have worked on in Algebra 1, Algebra 2, where if I have a number squared minus another number squared, it's equal to the same thing as a plus b times a minus b. So we're actually going to be using that. So my top actually ends up being sine squared theta plus cosine squared theta times sine squared theta minus cosine squared theta. And the bottom is sine squared theta minus cosine squared theta. And I want you to notice these two cancel out. I'm left with sine squared theta plus cosine squared theta. And guess what? We got our 1. So again, as you're working on these, just keep some identities in mind. Remember our little formula sheet. That will help a lot. Alright, but as you're working on your problems, keep those in mind. Ask questions if you need help.